students, this is lesson 9.1. We're starting chapter 9, which is quadratic functions. And we're going to start with just a little bit of review of some of the things that you need to know to be successful in this chapter. I'm just going to do one from each set here. So I'm going to pick one that I think is important. This one's kind of important that you're able to evaluate something like that. And all we're going to do is substitute the values in. So we're going to do 3 squared. If it's a positive number, I'm not going to use parentheses, but when I'm squaring things, if it's a negative number, I better use parentheses. So to show this, so we're going to do negative 4 times negative 1 times negative 2, substituting in those values for A, B, and C. And then on the bottom, we're going to do 2 times negative 1. You're going to have to do this carefully, otherwise you'll probably get an error. But on top, we're going to have 9 minus 8, and this positive here and this positive, or those two negatives, when you multiply them, they make a positive. So 4 times 2 is 8, and then we're going to divide that by 2 times negative 1, which is negative 2, and that's negative 1/2. All right, graphing functions. To graph a function, you should just make a table of values and then plot the points. I'm going to do number 11, y equals 2 times the absolute value of x. I'm going to put it on this graph right here. So let's just make a quick table of values, x, and then y is 2 times the absolute value of x. So if you remember from doing these absolute value functions before, they make a V shape, and that's because at some point the x's change direction because of the absolute value sign. So I'm going to choose these values, some negatives and some positives, so we make sure we see where it changes directions. If I take the absolute value of negative 2, that's positive 2 times 2 is 4. And we get 2, then we get 0, 2, and 4. Plotting those points, I get a graph that looks like this. And I know that once I get going in a certain direction, it's going to keep going in that direction. But at negative 1, I'm positive 2 again. So I get a V shape like that. All right, evaluating function rules. All that means is we are going to substitute in x equals negative 6 into the function to get the output. So negative 6 is our input. I'll do number 17 here. So we're trying to find g of negative 6, and to do that, all we have to do is substitute negative 6 for x. Again, I'm going to use parentheses. If you did this on your calculator and didn't use parentheses, you might get the wrong answer because negative 6 squared, and we need to do that first because of the order of operations, that's positive 36. So we get 2/3 times 36. And 2/3 of 36 is 1/3 of 36 is 12, so 2/3 of 36 is 12 times 2, which is 24. And that's because 36 divided by 3 is 12. All right, factoring. This is a review of last chapter. We're going to be using this some more. I'm going to do number 23. That seems like one of the more difficult ones to factor. To factor that, we need to find 2 numbers that have a product of 12 times negative 15, which I believe is negative 180, and they have a sum of 8. And right away I'm thinking, since that ends in 0, that 10 is a factor, so I think I can do 18 and negative 10. That would have a product of negative 180 and a sum of 8. So I'm going to do 12y squared plus 18y minus 10y minus 15, and then factor the first 2 terms. That would be 6y is the greatest common factor of those 2 terms, and then we get y plus 3, and then I need to get y plus 3 again, so I have to think about what do I factor out of negative 10 and negative 15 to get that, and that would give me, little mistake there, that should be 2y plus 3. So 2y plus 3. And if I factor out a negative 5, that would give me negative 5 times 2y is negative 10y, and negative 5 times 3 is negative 15. So finishing my factoring, I get 6y minus 5 times quantity 2y plus 3. All right, a couple of these definitions I want to go over here. It says use your knowledge of the definition of a quadratic polynomial to make a conjecture about the definition of a quadratic function. A quadratic polynomial, if you remember right, that's where the highest term is 2. So a quadratic function is the same thing. It'll look something like this. It could be a trinomial or not, but we know that the highest term in this function is going to be a squared. So there could be some other lower degree terms with it, but the highest term is a 2. The graph of a quadratic function is a U-shaped curve that has an axis of symmetry. What do you think that means? That means it's symmetrical. So the axis of symmetry is the line of symmetry. So let's just say there's a line of symmetry. All right, and this last one says this is the following example of zero product property. We're going to use this a lot in this chapter. It says the quantity x plus 3 times quantity x minus 4 equals 0. So x plus 3 equals 0 or x minus 4 equals 0. What do you think this means? Well, when you're multiplying, the only way you can get a product of 0 is if you're multiplying by 0. So basically, we can boil this property down to this. If you're multiplying two numbers and they equal 0, then either, so let's say if this, then either A equals 0 or B equals 0. If one of those aren't 0, then there's no way that the product can be 0. All right. So 9.1, quadratics and their graphs. We're going to learn how to graph quadratic functions of the form y equals ax squared and y equals ax squared plus c. Go ahead and do this review. I'm going to pause now, and you can check back for your answers. All right, important concepts here for you to know is a quadratic function is a function where the highest powered term is the second degree. And when you do that, you're going to get a parabola. The parabola may open upward or downward. If it opens upward, then the vertex is at the minimum point. If it opens upward, upward, then the vertex is at the minimum point. If it opens downward, then the vertex is at a maximum point. And that parabolas are symmetric, and that there's actually an axis of symmetry. And since that's a vertical line, it's some equation like x equals some point, wherever the vertex is. So, all right, so here we go. What is the vertex of this graph? Is it a minimum or is it a maximum? Okay, if you look at this graph, you can see that the vertex is at the highest point of the graph right there. And since it's the highest point, then it's a maximum. So our vertex, and then we just want to give the coordinates of that vertex point, and that would be -1, 4, and it is at a maximum function value. All right? Go ahead, you can try that. All right, it says graph the function y equals 1/2 x squared by making a table of values. What are the domain and range? Now, just a quick review. Domain, that is the x values for the function or the inputs. And the range is the y values or the outputs. All right, so we're going to make a table of values. I'll help you get started on that, and then I'll let you fill it in. I'm thinking we should do values like -6, -4, 2, -2, 0, 2, 4, and 6. remember this is going to be a symmetrical thing, so we want to get some positives and negatives to see where it changes and where the vertex is. All that. So, and I'll do the first one with you so you can get an idea how to do it. So we want to do 1/2 times -6 squared. -6 squared is 36. Half of 36 is 18. Go ahead and fill in the rest and then graph it. See if you get the right thing. So on this graph, this is 2, 4, 6, 8, 12, 14, 16, 18. So our first point is -6, -18. That would be right there. Then we have -4, -8. -4, +8. -2, 2. 0, 0. And if you notice when you're doing the math, now they're becoming a mirror image of what they were before, which helps us when we're graphing it. And then we're just going to draw a curve to represent that. It opens up. The vertex is at 0, 0. Now the domain is the possible x values, the inputs. And the possible x values are really all real numbers. There's no number that you can't square. So we'll say all reals, or we do this in interval notation. Anything from -infinity to infinity. And that's the domain. The range, the y values, notice that we have a minimum here. So the range stops at 0 and then it starts back up again. So the range is not all real numbers. It's really any positive number or any number greater than or equal to 0. So where x can be anything, y must be greater than or equal to 0, and that's the range. And if I do that in interval notation, that would look like we would include 0, and we would go to positive infinity with that one. All right, I'll let you try that. All right, what is the order from widest to narrowest graph of quadratic functions? F of x equals 2x squared, f of x equals -1/3 x squared, and f of x equals 4x squared. The widest to the narrowest, well, the higher the number you multiply by, the more the output increases by. So basically think about this, which has outputs increasing or decreasing the fastest. So if the outputs increase faster, then it's going to be narrower. And so the higher the number, the higher the coefficient of the x squared term, the narrower it's going to be. So the widest one will be the f of x equals -1/3 x squared. Then f of x equals 2x squared. And then f of x equals 4x squared. Now we could just put those on our graphs and see which would be narrower, which would be wider. Or we could also create a table of values and see. I think I want to look at a graph just to make sure that I'm doing that correctly. So I'm going to use my calculator. All right, so here I put in each of those functions, and now I'm going to graph them, and then we'll graph them in order. So the first one you see is 2x squared, then -1/3 x squared. So there's 2x squared, -1/3 x squared, and 4x squared. And if you lost track of them, one thing you could do is just trace and then use your up arrow to change graphs. So now I'm on 4x squared. Now I'm on 1/3 x squared. And you can see that the -1/3 x squared is definitely the widest of the graphs. All right. Now, how is the graph of f of x equals 2x squared plus 1 different from the graph of f of x equals 2x squared. Let's just look at some values, output values, and check that out. So if I do 2x squared here and 2x squared plus 1 for outputs, and I'm just going to pick some simple numbers, 1, 2, 3, so on. 2x squared is just 0, and so this one is just 1 more than that, so 1. If x is 1, x squared, 1 squared is 1 times 2 is 2, and then add 1 to that. So here we would get 8 and 9 and 18 and 19. So we can see that the output values for 2x squared plus 1 are just 1 more than the output values for 2x squared. So if I change the output, that's the y values. So if I graph this, you would see, but basically, think about this. I have to go over 1 here up 2. For this one, I go over 1 up 3. So it's just going to be 1 higher. So the graph will be shifted 1 unit up. And this is kind of a review of what we've done before. So let's just think about these other ones. What would it take to be shifted 1 unit down? In other words, what function, how would we change that so that we would shift it 1 unit down, and that would just be subtract 1 from the outputs, 2x squared minus 1. To shift it 1 unit left, that's where we want to change the input, so we move it along the x-axis, and to move it left, you might recall that we would actually add 1 to each of the input values. So that we would write that way, and to shift it 1 unit to the right, we would actually subtract 1 from the input values. All right, I'll let you go ahead and do this and figure out how that's changing. All right, child drops a pebble from a height of 30 feet above a lake. The function h equals negative 16t squared plus 30 gives the height h of the pebble and feed after t seconds. What is a graph quadratic function? So just a quick picture of this. So somehow a child is maybe in a tree. It has a branch coming out. And the child is out here, and down here is the water. And that distance is 30 feet. And the kid is dropping a rock into the water there. All right. So let's just find some values. And I'm thinking it's not going to take very much time to get to the water. So I'm going to use some really small increments of time. Like maybe I'm going to go 0, 1/2, 1, 1.5 seconds, up to 2. Maybe I'll need more than that. I don't think so though. But and then I'm going to use this function negative 16 t squared plus 30. So if I put in 0 for t, I get negative 16 times 0 squared plus 30, and that is 30 at 0. At 1/2, I'm going to do 16 times 1/2 squared plus 30. 1/2 squared is 1/4, and 1/4 of negative 16 is negative 4 plus 30 equals 26. At 1 second, I'm going to have negative 16 times 1 squared plus 30, and that's negative 16 plus 30, which is 14. At 1.5, I'm going to write this way, negative 16 times 3/2 squared plus 30. 3/2 squared that's 9/4 plus 30, and 16 divided by 4 is 4. Negative 4 times 9 is negative 36 plus 30 equals negative 6. And I'm not going to do any more because I now am getting negative heights, which means the pebble has hit the water. So now I'm going to graph this. And I think on my graph, on my x-axis, I'm going to go by half. So here we have, actually, I can put 1/2 here, and 1, and 1.5, and 2 out here. And then my height has to go up to 30. I'm just going to go by 5s. 5, 10, 15, 20, 25, 30. At 0 seconds, I'm at 30. At a ½ second, I'm at 26. At 1 second, I'm at 14. And at 1.5 seconds, I'm actually at -6. So that's going to be somewhere down here. But my line is going to go down. And you might think about what this means. This curve down, it keeps getting steeper going down, and what that means is the rock keeps going faster and faster. Question says, about what time does the pebble hit the water? And another thing you might think about is, why didn't I use negative values here? Think about what our domain is, our natural domain. We really can only have positive values for t. But it looks like, I'm going to just guess that the time it hits the water is about 1.4 seconds, according to the information here. All right, go ahead, you try that. All right, wherein is the vertex of a parabola minimum point? When is the maximum? Draw a line from each function in A to the description of its graph. If it's a negative x squared, it will open down. If it's a positive 1x squared, it'll open up. And basically, it has to do with the coefficient of the quadratic term, or the x squared term. If it's a negative coefficient, then it's going to be a maximum, because it opens down. If it's a positive coefficient, then it's going to be a minimum, because it opens up. All right, that's the lesson. I'll see you tomorrow.